Hello there, I'm Borna, your organic chemistry tutor, and I brought yet another mechanism problem for you today. Let's get started. Alright, this is the reaction we're going to be discussing today. You should be able to do the mechanism for this reaction if you have learned the SN1, SN2, E1, E2 chapter. If you have, I highly recommend that you pause the video and try this mechanism on your own, and I'll be with you in a second. Alright, let's see if you did it right. Looking at this reaction, what is going on is that we have an alkyl halide right here, which is tertiary, and then we have an alkene in the product. So it seems like some sort of elimination. We don't have a strong base, so E1 seems to be a reasonable pathway. But we have had a rearrangement going on here. We have gone from a 4-membered ring to a 5-membered ring, which is consistent with the formation of a carbocation because carbocations can rearrange. Alright, so first step of the reaction, leaving group is going to leave. We're going to be left with a 4-membered ring adjacent to a tertiary carbocation. And if this carbocation moves this ring bond over, it can create a 5-membered ring and a secondary carbocation. Now you may be wondering, well, we are going from a tertiary carbocation to a secondary carbocation, which is less stable, and you'd be right, except we are going from a 4-membered ring to a 5-membered ring, and the energy difference between a 4-membered ring and the 5-membered ring is greater than the energy difference between a tertiary carbocation and a secondary carbocation, meaning the stability gained by relieving the ring strain is greater than the instability gained by going from a tertiary carbocation to a secondary carbocation. Now, in order to get to the product, the two methyls have to be on adjacent carbons, so this methyl is going to shift again, and that is going to give us a carbocation here, and all that needs to happen now is for that to basically lose a hydrogen and give us the product. Carbocations can do three things. They can rearrange, they can react with the nucleophile to give a substitution product, or they can lose a hydrogen to give us an elimination product, and that is what is going on here. We lost the hydrogen and we got the elimination product. Here we go. I hope you liked this video. If you did, please hit the like button. Also subscribe to see more solved problems and tips and tricks and tutorials. Check out my website at eurochemtutor.com, and I'll see you next time in the next video. Take care.